viewers, this is the Science Demystified, your number one tutor on this channel. In today's lesson, I will be taking you through how to balance redox equations in acidic medium and alkaline medium. So without wasting much of your time, let us go to the board and demystify the process. So without wasting much of your time, let us look at a sample question that involves balancing of an ionic equation in an acidic medium. Now look at this question. This is an ionic equation and we are asked to balance it in an acidic medium. So the first thing I need to do is to split the overall ionic equation into two half equations, in which one will be the oxidation half equation and the other one will be the reduction half equation. So you can see obviously that from here to this place, the oxidation state of chromium dropped from 6 to 3. So that is reduction. So this is the reduction half equation. Is Cr2O7 to Cr3 plus. Okay, so this is my reduction half equation. Reduction. Okay, so now the oxidation half equation will automatically be the next, reaction, which is HNO2 being transformed to NO3. Now, obviously, you can see that the oxidation state of nitrogen changed from here from nitrate 3 to nitrate 5. So that is oxidation. So this is an oxidation reaction. So we have HNO2 metamorphosizing into NO3 minus. So this is the oxidation equation. So having done this, the next thing I need to do is to follow a set of rules which I'm going to be telling you now. Now the first rule is to balance any atom that is not hydrogen or oxygen in the two half equations that you have written. Balance any atom that is not oxygen or hydrogen in the two equations that you have written. Now in the first equation, you can see that chromium is obviously the atom that is neither oxygen or hydrogen in the equation. So I'm going to balance chromium in equation 1. So that will take us to Cr2O7, 2 minus. Now here we have 2 atoms of chromium on this side. So I will now add 2 atoms. I will now add 2 in front of the chromium here to make it 2 atoms. So I have balanced the chromium atoms for the reduction half equation. Now let me do the same thing to the second equation. Now if you look at the second equation, nitrogen here is an atom that is neither hydrogen nor oxygen. So unfortunately, nitrogen is already balanced in the equation. So I will not balance it again since it's already balanced. So I have obeyed step 1. I have obeyed step 1, which says I should balance any atom that is neither hydrogen nor oxygen in the equation. Now the next thing I need to do is to balance oxygen atoms by adding to the opposite side where we have deficient oxygen an appropriate number of moles of water molecule to balance the oxygen atom. Okay, that's the next thing I'm going to do now. So in equation 1 we have Cr2O7 2 minus, and it produces 2 Cr plus. That's this. Okay, so I'm expected to add to this side. Now here we have 7 atoms of water here, so that will make me to add 7 moles of water to balance oxygen in the equation. So I will do the same thing to equation 2. In equation 2, we have 2 atoms of oxygen here, and we have 3 atoms of oxygen here. So I'm expected to add also water to the equation to balance the number of oxygen atoms. I will be back shortly. Alright, so having added 7 moles of water to the product side to balance the number of oxygen atoms we have in the equation. I will do the same thing in my oxidation half equation. I will do the same thing. Here we have more of oxygen atoms in the product side than the reactant side. Okay, so here I'm going to add water here in this side of the equation to make oxygen now to be 3 atoms. So that will balance with the O3, that's the 3 atoms of oxygen we have on the right hand side. So having done that, the next thing for us to do is to balance hydrogen atoms in the oxidation half equation and also in the reduction half equation. To balance hydrogen atoms, you simply need to add hydrogen ion, required number of moles of hydrogen ion on the side that is deficient with hydrogen. Okay, let's go back to the oxidation half equation. So this is the oxidation half equation. So you can see here we have 7 times 2, that's 14 atoms of hydrogen in the right hand side. So that will make me now to add 14 moles of hydrogen ion to this side for me to balance the number of hydrogen atoms. Okay, so now to the oxidation half equation, I'll do the same thing. In the oxidation half equation, we don't have hydrogen in the right hand side, so I have HNO2 plus H2O. Now if you calculate the total number of hydrogen atoms we have here, we have 3 hydrogen atoms in all. Okay, so that will now make me to add 3 moles of hydrogen ion to the product side. 3 moles of hydrogen ion to the product side to balance the number of atoms of hydrogen. So, having balanced oxygen atoms and hydrogen atoms in the oxidation and reduction half equations, the next thing you need to do is to balance the charge. To balance the charge, I mean you have to sum up all the charges on the right hand side and balance it with the charges on the left hand side of the equation. So let us begin with the reduction half equation. Now here we have minus 2, that is in the the reduction half equation. We have Cr2O7 2 minus plus 14H plus to give 2Cr3 plus and 7 moles of water. Okay, so to check all the charges we have on the left hand side, this is minus 2 from this radical, and this is plus 14. This is plus 14 because here is plus 1, so 14 times plus 1 will give us plus 14. Okay, so altogether we have a total of 12 positive charges on the left hand side, and when we compare it to this side, here we have 2 times 3 plus, which is 6 plus 6 positive charges. So you can see that at this point the charges are not the same, they're not balanced. So for me to balance the charge, I need to add appropriate number of moles of electron to the side that has more positive charge for me to reduce it and make the number to be the same. So to do that, it means I need to add 6 moles of electrons to the left hand side. 6 moles of electron to the left hand side. I hope you can see it. So my equation will now look like this: Cr2O7 2 minus plus 14H plus, then plus the 6 electrons I'm adding to reduce the excess positive charge. Okay, and that will give us 2Cr3 plus and 7 moles of water. Okay, so we have balanced the charge for the reduction half equation. So let us now balance the charge for the oxidation half equation. Let us balance the charge now for the oxidation half equation. Okay, now for the oxidation half equation, the equation is HNO2 plus H2O water to give NO3 minus plus 3H plus. So if you check, this is a neutral molecule, this is a neutral molecule, so the total charge we have is 0. So but on this side we have minus 1 plus 3, and that will give me plus 2. So the charge is 0 and plus 2, right? So to balance the charge on the right hand side, I need to add 2 moles of electron to this side to make it balance with the one I have here. So that will now make me to write the equation like this: HNO2 plus H2O, and that will give NO3 minus plus 3H plus, then plus 2 moles of electron. So after this step, the next thing you need to do is to make sure that the number of moles of electron that's accepted in the reduction half equation is equal to the number of moles of electron that is given out in the oxidation half equation. Now to achieve that, if you look at the reduction half equation, we have 6 moles of electron accepted, but here we have 2 moles of electron given out. So to step this equation up to make it to be like this one, to be 6, I need to multiply the equation I just created by 3. I need to multiply every single component of the equation by 3. So to do that, that means this compound will now be 3HNO2 plus 3H2O to give 3NO3 minus plus this one automatically becomes 9H plus, right? Then plus 3 times to give me 6E minus. So at this point, I'm at the close of this balancing of our redox equation. So the next I'm going to do is to join my reduction half equation with my oxidation half equation and possibly cancel out the equal number of moles of electron that I generated with 2 half processes. Okay? Alright, so that is what I'm going to do now. Let us join our oxidation half equation with our reduction half equation. So the oxidation half equation is Cr2O7 2 minus plus 14H plus 6E minus. So I will now add this other side. Remember, this is the reactant side, this is the product side, this is the reactant side for my oxidation for my reduction half equation. And I'm going to add it with the reactant side of the oxidation half equation. So I'm joining it together. So this 3HNO2 plus 3 moles of water, So I will now join the product. The product will start with the one I have here, that's 2Cr2. That's the product that we obtained in the reduction half equation, which is 2Cr3 plus 7H2O water, then plus the product side, what we have here, the product side, and that is 3NO3 minus plus 9H plus 6 moles of electron. So at this point, I will begin to cancel equal terms. Okay, so this is 6E minus, cancelling 6E minus, and cancelling the electrons used in the redox equation. Okay, so the next one is for me to check if there is any similar species that I need to cancel out as well. So here we have water. You can see water molecule about 3 moles of water, and here we have about 7 moles of water. So removing 3 moles of water from 7 moles of water, it will remain 4 moles of water. Okay, so I have removed water from the equation, but it's still remaining about 4 moles of water. So the overall redox reaction will now look like this. The overall redox reaction will now look like this. So we have Cr2O72 minus plus 14H plus 3HNO2. That will give us 2Cr3 plus 4H2O plus 3NO3 minus plus 9H plus. So this is the balanced ionic equation for the redox reaction. So this is the much we can take for today. In my next lesson, I will be taking you through balancing of redox equations in alkaline or basic medium. So for now, we are done for today's class. So if this is the first time you are watching me live on this channel, please do me this favor. Click the subscribe button below to subscribe to this channel. If you are an old subscriber, like I always say, whatever you want us to do, we are at your service. So just drop it on the comment section. If there is any lesson you want us to, help you to explain or to elucidate, we are here at your service. Do that in the comment section. But please, once more, don't leave without hitting the subscribe button, because that's the only way you can encourage us to grow. Thank you for watching. See you in my next video.